When adding fixed multi-outlet assemblies, or FMOAs, to a hotel room, several code implications must be considered. Firstly, circuit loading. Each FMOA typically has 6 receptacles, which can significantly increase the load on the circuit. The National Electrical Code (NEC) requires that the load on a circuit does not exceed 80% of the circuit ampacity. Adding an FMOA may violate this requirement, especially on circuits already near capacity. Secondly, branch circuit requirements. The NEC requires that each guest room in a hotel have multiple branch circuits to provide power to various appliances and electronics. Adding an FMOA may not provide sufficient power for all devices in the room, especially if multiple devices are plugged into the FMOA simultaneously. Thirdly, tamper-resistant receptacles. The NEC requires that all 15 amp and 20 amp receptacles installed in guest rooms be tamper-resistant to prevent electrical hazards. Many FMOAs include standard receptacles that do not meet this requirement. Fourthly, fire safety concerns. Overloading circuits can lead to overheating, which can increase the risk of electrical fires. FMOAs can also create tripping hazards and make it difficult for occupants to evacuate the room in case of an emergency. Fifthly, ground fault circuit interrupters, or GFCIs. All receptacles in bathrooms and other wet areas in a hotel room must be protected by GFCIs. FMOAs may not provide GFCI protection for all of the receptacles they serve. To address these concerns, consider several mitigation measures. Evaluate circuit load. Before adding an FMOA, calculate the total load in the circuit and ensure that it will not exceed 80% of the circuit ampacity. Provide additional branch circuits. If the circuits in the room are near capacity, consider adding additional branch circuits to meet the increased demand. Use tamper-resistant FMOAs. Install FMOAs that include tamper-resistant receptacles to comply with NEC requirements. Address fire safety concerns. Ensure that FMOAs are securely mounted and do not create tripping hazards. Consider using surge protectors to prevent overloads. Provide GFCI protection. If the FMOA does not have built-in GFCI protection, install GFCI receptacles in wet areas or consider using GFCI-protected FMOAs. To expand on these points, let's consider the specific sections of the NEC that might apply. Article 210 covers branch circuits, and it details the requirements for the number and type of branch circuits required in dwelling units and guest rooms. Section 210.11 specifically addresses the number of branch circuits, and it may require additional circuits if the load calculation indicates that the existing circuits are insufficient. Furthermore, 210.21 and 210.23 outline the permissible loads on branch circuits, specifying the maximum allowable ampere rating of the overcurrent device and the connected loads. For example, a 20 amp branch circuit, using the 80% rule, should not have a continuous load exceeding 16 amps. With 6 receptacles on an FMOA, it is easy to exceed this limit if multiple high-power devices are connected. The calculation of the load needs to consider both the general lighting and receptacle load, as well as any specific appliance loads that are likely to be connected. Section 220.14 provides guidance on calculating receptacle loads, specifying the volt-ampere value assigned to each receptacle outlet. For guest rooms, it's essential to consider the potential for multiple electronic devices such as laptops, smartphones, and tablets, each drawing power simultaneously. In addition to circuit loading, the type of receptacles used in FMOAs is critical. As mentioned earlier, Section 406.12 requires tamper-resistant receptacles in dwelling units and guest rooms. These receptacles are designed to prevent children from inserting objects into the slots, reducing the risk of electrical shock. If the FMOA does not include tamper-resistant receptacles, it would violate this requirement, necessitating the replacement of the FMOA or the installation of separate tamper-resistant receptacles. The NEC also addresses the proper wiring and grounding of receptacles. Section 250.146 outlines the requirements for grounding receptacles, ensuring that they are properly connected to the grounding system. This is crucial for preventing electrical shock and ensuring the safe operation of electronic devices. The grounding conductor must be properly sized and connected to the grounding electrode system to provide a low impedance path for fault current. GFCI protection, as required by Section 210.8, is essential in wet locations, such as bathrooms and near sinks. GFCIs detect ground faults and quickly interrupt the circuit, preventing electrical shock. If the FMOA is used in a location where GFCI protection is required, it must either include built-in GFCI protection or be connected to a GFCI protected circuit. It is also important to consider the physical installation of the FMOA. Section 400.8 restricts the use of flexible cords and cables, prohibiting them from being used as a substitute for the fixed wiring of a structure. The FMOA should be securely mounted to prevent tripping hazards and ensure that it does not put undue strain on the receptacle it is plugged into. The cord of the FMOA should be of appropriate length and gauge to handle the anticipated load, and it should not be run through doorways, windows, or other openings where it could be damaged. Fire safety is another significant concern when using FMOAs. Overloaded circuits can lead to overheating, which can ignite nearby combustible materials. Section 310.15 specifies the ampacity of conductors, and it is essential to ensure that the wiring in the circuit is of sufficient size to handle the anticipated load. Using surge protectors in conjunction with FMOAs can help protect electronic devices from voltage spikes and surges, reducing the risk of damage and fire. Regular inspections of the electrical system, including the FMOAs, can help identify potential hazards and ensure that the system is operating safely. It is also crucial to educate hotel staff and guests about the safe use of FMOAs, emphasizing the importance of not overloading circuits and avoiding the use of damaged or frayed cords. In addition to the NEC requirements, local building codes and regulations may impose additional restrictions on the use of FMOAs in hotel rooms. It is essential to consult with the local electrical inspector to ensure compliance with all applicable codes and regulations. The electrical inspector can provide guidance on the proper installation and use of FMOAs, as well as answer any questions about the interpretation of the NEC and local codes. Proper planning and attention to detail are essential when adding FMOAs to hotel rooms. By carefully considering the code implications and implementing appropriate mitigation measures, it is possible to provide guests with convenient access to additional receptacles while ensuring the safety and reliability of the electrical system. The key is to balance the need for convenience with the paramount importance of electrical safety. Ensuring the electrical system meets the demands of modern electronic devices while adhering to strict safety standards is a crucial aspect of hotel management and maintenance. In summary, when adding fixed multi-outlet assemblies or FMOAs to hotel rooms, remember to firstly evaluate circuit loading to ensure it does not exceed 80% of the circuit ampacity as per NEC regulations. Secondly, provide additional branch circuits if the existing circuits are near capacity to accommodate the increased demand. Thirdly, use tamper-resistant FMOAs to comply with NEC requirements for safety in guest rooms. Fourthly, address fire safety concerns by securely mounting FMOAs and using surge protectors to prevent overloads. Fifthly, ensure GFCI protection is provided, either through built-in GFCI protection in the FMOA or by installing GFCI receptacles in wet areas. By adhering to these guidelines, you can ensure the safe and compliant use of FMOAs in hotel rooms, providing convenience for guests while upholding electrical safety standards. It is also advisable to consult with a qualified electrician or electrical inspector to ensure compliance with all applicable codes and regulations. Regular maintenance and inspections of the electrical system, including the FMOAs, are essential to identify and address any potential hazards. In addition to the above points, it's important to consider the potential for voltage drop when using FMOAs, especially if multiple devices are connected simultaneously. Voltage drop occurs when the voltage at the receptacle decreases due to the resistance of the wiring. Excessive voltage drop can cause electronic devices to malfunction or operate inefficiently. To minimize voltage drop, it is essential to use wiring of adequate size and length and to avoid overloading circuits. The NEC provides guidance on calculating voltage drop and specifies the maximum allowable voltage drop for branch circuits. Furthermore, consider the placement of the FMOA within the hotel room. It should be located in a convenient and accessible location for guests, but it should also be positioned to minimize tripping hazards and prevent damage to the cord. The FMOA should be securely mounted to a stable surface, and the cord should be routed in a way that prevents it from being pinched or damaged. It is also important to ensure that the FMOA is not located near flammable materials or in areas where it could be exposed to moisture. In addition to surge protectors, consider using power conditioners to protect electronic devices from voltage fluctuations and noise. Power conditioners can help stabilize the voltage and filter out electrical noise, ensuring that electronic devices operate reliably and efficiently. Power conditioners are particularly beneficial for sensitive electronic equipment, such as computers and audiovisual equipment. Finally, it is essential to keep accurate records of all electrical work performed in the hotel room, including the installation of FMOAs. These records should include the date of installation, the type of FMOA used, the circuit number, and any modifications made to the electrical system. Accurate records can help facilitate future maintenance and troubleshooting, and they can be valuable in the event of an electrical incident. The use of FMOAs in hotel rooms can provide guests with a convenient and flexible way to power their electronic devices. However, it is essential to carefully consider the code implications and implement appropriate mitigation measures to ensure the safety and reliability of the electrical system. By following the guidelines outlined in this discussion, hotel operators can provide a safe and comfortable environment for their guests while complying with all applicable codes and regulations. To reiterate the importance of these safety measures, it's crucial to remember that electrical safety is not just a matter of compliance, but a matter of protecting lives and property. Taking the necessary precautions to prevent electrical hazards can help ensure the well-being of hotel guests and staff, and it can also protect the hotel from costly damages and liabilities. Regularly reviewing and updating electrical safety procedures is an essential part of hotel management, and it is a responsibility that should be taken seriously. In conclusion, the decision to add fixed multi-outlet assemblies, or FMOAs, to hotel rooms involves a multifaceted assessment of electrical codes, safety considerations, and practical implementation. By adhering to the NEC guidelines, local regulations, and best practices for electrical safety, hotel operators can provide a valuable amenity for their guests while ensuring a safe and reliable electrical environment. It's a balance of convenience and caution that ultimately contributes to a positive guest experience and the overall well-being of the hotel.